All right. Hello, everyone. Welcome to week 3 of CQMS703. How is everybody? Can somebody confirm that you can hear me and you can see my screen? Okay, great. I see a thumb up. Okay. Are there any questions, anything? You can type in your questions in chat area, or you can unmute yourself. Okay, before I start the class, just some logistics, cost management. I posted the data file on D2L. Finally, I got data file from publisher. So go to our website. Under the content, we have data. The last item is the data from publisher for this textbook, Hanker data underscore set. Okay. Throughout the term, I may provide other data. I already provided some data here. Okay. So if you want to follow my steps along, you need to download this data to your computer. The Hanker data underscore set. This is the data file from textbook. Okay. Another item I posted is the class notes. Under class notes, I also get the permission from publisher to publish the odd numbered solutions from the textbook. Again, it is a zip file. You need to download to your computer and unzip it. Okay. So any questions?
Yes, Professor, I had a quick question just regarding Excel. I was wondering if you could show us quickly, whenever you get the chance, how to compute the critical value one more time.
Oh, sure. Thank you. So the question is about the critical value in Excel. So I'm going to open Excel. So most often, so far, we are going to use T critical value, okay? Critical value for T. So I'm going to give you a problem, okay? So for example, so if I give you maybe any percentage, say 93%, and I ask you what is the critical value here? Suppose this is two-tailed test, and suppose sample size is given. Okay, the question is, what is the critical value? What is this point or this point? This is the question. You can use Excel to do it. Just try to make this, okay. So in Excel, I'm going to copy formula. You type in equal T dot INV dot 2T, opening bracket. So this probability refer to the areas on both sides. If you have a 93% confidence level, the area on both tail is 7%. Okay, so 7% is the same as 0.07. And then you type in degree of freedom is sample size -1 if this is one sample. Okay, so the formula is T dot INV dot 2T. And then probability, you type in areas on two tail. What is the area for two tail? And you press enter, you got 1.87. Okay, so if you can do this question, you can do any questions. Okay, Control C. Just going to copy this. Okay. Okay, so this is a given 93%. Most often you are given 95%. Okay, so we get 1 point. What is the number? 1.8708. Okay, so hope that answered your question, how to figure out critical value on Excel. Any other questions? Who can see your, okay. Any other questions?
Professor,
yes, please.
how do we know when to use like a T critical value or a Z critical value? Isn't the cutoff like 30, like something like that?
Good question. The question was, how do we know we use critical T value or we know critical T value? One criteria you mentioned that is correct is sample size greater than 30. You can use Z critical value. And if sample size smaller than 30, you can use T critical value unless it is specified otherwise. So because when you have sample size greater than 30, that is the implication of normal distribution. When you have sample size smaller than 30, that is not normal distribution. We assume it is a T distribution. Okay, so that is how do you know critical value for Z or critical value for T? Okay, any other questions? All right, so now the agenda for today, we'll continue chapter 3. We haven't finished yet. We do the continuation by doing some problems in the textbook, examples from textbook, okay? And then we'll start chapter 4, moving average. We cannot complete chapter 4, so next week, we continue chapter 4. If time permit, we may start chapter 5, that is next week, okay? So now I'm going to start with a textbook example. That is 3.1, chapter 3.1. It is about random data. I will use different data set as textbook. The point is to show you how do you know this is a random data based on autocorrelation function. Autocorrelation function, okay? So suppose I'm going to give you some data, okay? This data it is random. How do I prove this is random data? Try to move this. Right. Okay, I'm going to create random data set, and then I am going to prove this is random data using autocorrelation function. Okay, so to create random data that has a normal distribution, so I type in norm.inv, opening bracket, and then it asks me the probability. We all know any probability is between 0 and 1, because I want to create a random number. So I will use RAND, that is random number generator. This RAND will provide a random number between 0 and 1. And then I will give the mean value and standard deviation. Okay, suppose the mean value is 75, standard deviation is 13, just for example. Okay, so I want to create a random number. Mean is 75, standard deviation is 13. Okay, I may not need those decimals, but I will maybe have 100. Doesn't matter, maybe 200 is fine. I get 200 random number. Okay, I don't want those decimals, so I'm going to just have the whole numbers here. Okay, so those are the random number I get from Excel. And next, how do I prove? If you don't know if this is random number or not, how do you use autocorrelation to identify this is random number? Okay, so that is our task. So to do that, we need to get the autocorrelation coefficient. Okay, so remember we have Excel or we have SPSS to get that graph and also to get that number. So now I'm going to copy this data into SPSS. So I just select copy, Control C, copy. I open SPSS. Maybe I will just paste it here. Okay, I'll paste it here. Control C, Control V. Okay, so I got this number, random number here. I just copy and paste. I will change the name from VAR008 to maybe RAND NUM, random number. Okay, I don't want decimal. All right, so this is my random number I created. And now I want to get autocorrelation. Okay, so how? You go to Analyze, Forecasting, Autocorrelation, Variable. I'm interested in random number variable I just created. Okay, in the options, by default, you are given a number of legs, 16, but most often our textbook at least use 10. Okay, number of legs. You click continue button and then click OK. And you will get, see this number here, autocorrelations here. Remember, you need a complicated formula to calculate, but since we are using technology, we just get this one here. So I'm just going to copy this on the side. So if you, and also we have this ACF, autocorrelation function, okay? Based on this graph, we can say, maybe I will copy this graph so that, maybe just copy the screen. I want to make annotation, okay? No. All right, so this is our upper limit, this line upper limit, and this is outer lower limit. If you have autocorrelation between upper limit and lower limit, that means the data are random because all this value close to zero. See, zero is here. This is zero. All the value very close to zero means data are not related to each other. Data are random. Okay, so this is based on this graph. And if you look at this number here, all these number, for example, the first number is 0.13, it is actually here. This is 0.13. The second number, negative 0.068, it is here, negative 0.68. Okay, so that answered our question. Are data random? That is actually example 3.1 from our textbook. Okay, 3.1 from our textbook. So we proved this data is random, not 3.1, sorry, actually it is 3.2. Okay, 3.2, data are random. Okay, so any questions?
Hi, Professor. I actually have a question, but it's about the homework. Are we going to be going over the homework at all?
We don't have a homework. It is suggested questions.
Yeah, so in chapter 3, there was questions from that were like questions 14 and 17 in chapter 3. I wasn't sure. So I was wondering if we could cover them if we had time.
Sure.
Because they were the ones that were assigned.
Yeah, thank you. So this is my plan. I'm going to do some selected questions from chapter 3. See, I listed here. Question 20, question 23, question 24. What other question do you suggest?
So in the problems in the Word document where you have the chapter problems, question 14 and 17 were assigned.
Thank
so
you.
We could do
Yeah,
that.
question 14 and question 17. Sure, we can do that. Okay. Thank you for mentioning that. By the way, remember I mentioned at the beginning, you have detailed solutions for odd numbered questions from the textbook. Keep in mind, you have the detailed solutions. Okay, so for example, question 17, you have solutions. Question 14, you don't have solutions. Okay, but since you mentioned those two questions, I will go over them. Okay. All right. So maybe I will go question 14 first. Okay. So question 14, I will pull out my textbook. Where is my textbook? So question 14, page 89. So this is the question, okay? Make it bigger. Question 4, oops, want to see the complete question, maybe make it. Just adjust my windows. Question. Okay, so I'm going to copy this into my OneNote. So that I can make annotation. All right, so question 14, compute 95% confidence interval for autocorrelation coefficient for time lag 1 for series that contain 80 items, means sample size n equal to 80. Okay, sample size n equal to 80. And then this question, if you check the textbook, like 1 confidence interval the formula is 0 plus minus z half alpha critical value times 1 over square root of sample size. You use this formula, okay? Use this formula. And then the question becomes, how do you find that critical value? How do you find the critical value?
Why is it 0?
Good question. Remember when we produce autocorrelation functions, this is 0. This point is 0. We always refer to 0. It is around 0. This line here. The mean is 0. That is the nature of the autocorrelation distribution. The mean is 0. That's why this line is 0. Okay. So, we use this formula. Okay. So next, how do you find the critical value for for 95%? Okay, we know it is 1.96, but in case you forget, so I'm going to use Excel to find critical value norm dot inv. Okay, norm dot inv, probability 0.05, mean is 0, standard deviation is 1. That is how you found. Actually, this is 95%. This is a normal distribution. The rule is different for normal distribution. So I have to use norm dot inv. Okay, so probability, I'm going to use 97.5%. I will explain, okay, later. Mean is 0, standard deviation is 1. Okay, so I got 1.96. I'm going to copy this. I need some space to explain here. So when you do normal distribution, this question gives you 95%. Okay. The Excel formula is based on area to the left. So our objective is to find what is this z half alpha. Excel based on area to the left of this z half alpha. When you have a central area 95%, so this part, the whole area to the left is 97.5% because this little tail is 2.5%. So 2.5% plus 95%, 97.5%. That is the reason I type in here 97.5% for critical value for normal distribution. Okay. So this z half alpha is 1.96, and then you just plug in, you can get the number. Okay, it is a positive, negative 0.219. Okay, so that is the confidence interval.
Can you explain why it's 1 over n?
1 over square root of n.
Yes.
1 over square root of n. That is the definition. I will show you the formula. It is the formula is here, page 87. Try to find the formula. So the standard error of autocorrelation is based on this formula, okay, 3.2. when you are talking about leg 1, this item is 0. We do not have the second item. So it's just square root of 1 over n. Okay. And then the constant interval, I'll try to find the exact formula. It is so remember what the CQMS703. The confidence interval is a mean plus minus critical value times standard error. Okay, so I'm trying to explain on the note here. So confidence interval, you use mean plus minus z½ alpha times standard error of R. K. So SE, when K equal to 1, it is equal to square root of 1 over n, or 1 over square root of n. Mean is 0. Mean is 0. Okay. Any other questions? All right, so that is question 14. Question 14. And then the data. Next, question 17. You mentioned question 17. Okay. So I go back to question 17. It is on page.
Can you just say what the final answer was? So what was the critical value? Was it 1.96?
1.96 is the critical value, yes.
Okay, and then it would be 1 over the square root of 80.
Right.
Okay, thank you.
You're welcome. So it is here. Okay. Maybe I'll write clearly. So 0 plus minus 1.96 times 1 over square root of 80. Calculate this number. All right. So next question, question 17. 17, page 90. I have to. Okay, this is page 17. Okay, so again, I will. Okay, so question 17. Analyze the bank's loan portfolio for years 2001 to 2006. Okay, the data is this one. Compute autocorrelations for time lag 1 and 2. Okay, and test to determine whether this autocorrelation is significantly different from 0 at 0.05 significant level. Okay. All right. So question. Just to get the data, remember I posted the data on D2L. You need to go to D2L, download the zip file, which one I'll mention it here again. Which one you need to download. You need, by the way, see all the numbered detailed solutions are here from textbook. So question 17 should be here in detailed solutions here. So I will just go through briefly. You have detailed solution for question 17, okay? And where is the data? You go to data, the last item, Hanke data underscore set is the data file from textbook, okay? So download this zip file on your computer and then unzip it or extract. So I already downloaded it. So I will directly go to that file. So it is here, data file, textbook. See, Hanker data set, Excel data set. And this is chapter 3. Yeah, chapter 3. And this question is problem 17. So I go to PR 17, this one here, problem 17, problem, chapter 3, 17. Double click to open this one. Problem 17. Oh, why it does not open it?
If you bring that other one, if you drag that other Excel file like up, it'll probably show up on like the bottom.
Thank
just
you.
have to
Yeah,
drag the table.
just too many Excel files here. So not this one is annoying. I will close this one without saving it. Somewhere it should be here, but this is problem book 3. No. Oh yeah, here. Okay. So this is the data. Okay. So enable editing. So first I'm going to copy this data. Oh, very first step, you do not work with original data. Always copy and paste the data to another location to preserve original data, okay? So I'm going to copy and paste to this worksheet here. So, no, add. So this is chapter 3, problem chapter 3, 17. Okay. Control C, Control V. Okay. And then I'm going to increase the font size. All right. So this is the data. Okay. And the question asks we to calculate the first autocorrelation for leg 1 and leg 2. Okay. For leg 1 and leg 2. So we, oh, is this the data? Yeah. Yeah, you can use formula, okay? You can use formula to calculate, but maybe it's more convenient to use SPSS. So I'll just copy this data, Control C, and go to Excel and paste here, Control V, and then go to variable view. So this question is about the problem in chapter 3, and then 17. Okay, chapter 3, 17. I don't need decimals. So this is the data. Okay, this is the data. Now, I may combine, there are two questions, question A and question B into one question, because question B asks you use computer program to plot the data and compute autocorrelations, okay? Actually, you can ignore question A, just go question B. You can get autocorrelations for first 6 time lags, see, 6 time lags, okay? And then answer the question, is the time series, is this data stationary? Okay. So once you get data from to SPSS, you go to analyze. Forecasting, okay. Autocorrelation, quick reset button, reset. Now we want variable, problem chapter 317, time lag is 6. Okay, time lag is 6. And then continue and click OK button. Okay, so you can see R1 is 0.895, R2 0.788 here.
Doesn't
Okay,
the question ask for time lag 1 and 2?
yeah,
So why did you use 6?
I combine question 1 and question 2 together.
Okay.
Okay, so you can check out the detailed solutions I posted on D2L. Okay, this one I just show you the autocorrelation graph. Yeah. 17. So this is R1, autocorrelation R1. This is R2. Okay, and this is a time lag 6 auto correlation graph. Obviously, you see, they are far beyond. This is the upper limit. This is lower limit. Okay, they are above upper limit. Okay, so the data are related to each other. Okay, data related to each other. So, any questions? All right. So actually, we did questions from textbook, and then I have additional questions on my list. Question 20. It is similar questions actually. Question 20. Just question 20. Okay, so I'm going to pull out question 20. It is on page 90. Okay, so this is question 20. Do we have data? A, B, C, D. This is A, B. So I'm going to copy this to OneNote. Oh. So try to find the rule. Okay, I can use this one here. Okay, question 20. An analyst would like to determine whether there is a pattern to earnings per share for the price company, which operated a wholesale, retail, cash and carry business in several states under the name Price Club. Data are shown in table P20. Oh, I have to locate P20. Okay, so you go to the same place on D2L to find the data file. Okay, I'll have the data P20. This is long. Try to log in. Yeah, here. So this is the data. Okay, this is the data. So what are we going to do with this data? Question A. Going to maybe copy this data. So this is the data. Okay, so question A, found the forecast value of the quarterly earnings per share for Price Club for each quarter by using naive approach. means use the forecast for first quarter 1987 is the value for fourth quarter of 1986. So just use the previous quarter, okay, to estimate the next value. Okay, so that is question A. Okay. Question B, evaluate the naive forecast using MAD. So that is the question. 1820. Okay, so let's go back to the question here. So those are the, let me see, questions. So to do the forecast, I'm going to insert a column. Insert. So this is quarter data. So quarter 1, quarter 2, quarter 3, quarter 4. Okay. So what are you going to do? You actually use check the requirement. The forecast for fourth quarter of the fourth quarter. So use previous quarter. So this is the price, this is the forecast. So if you want to forecast for this number 0.29, you just take the previous data equal to 0.4. That is the naive method. Okay. So press Enter key. Now, put your mouse on bottom right corner until you see fair handle. Double click, you get forecast for all other numbers. Okay. So we answered the first question. Okay, use naive method. And question B, calculate MAD. Okay, so you have to know what is the formula for MAD. The formula for MAD equal to use YT, original data, minus predicted data, Y hat T. Okay, and take absolute value. After that, add them all, add all the absolute value together, and then divided by N. This is MAD. Okay, and when you do calculation, this MAD, it is actually just the average of YT minus YT hat. So in Excel, you calculate YT minus YT hat, take absolute value. Okay, so go to Excel. This price is Y. This price is Y. Okay, the forecast is Y hat. So you are going to do the difference between YT and Y hat. So you do 0.29, that is YT, minus 0.4. 0.4 is YT hat. And you have to take absolute value. In Excel, it is ABS, represent absolute value. So I pause for a moment. The formula is, can we download data? Yes, you can download data, okay? The formula is A equal ABS, A3 minus B3. Okay, so that is what I did. I just did YT minus YT hat. So A3 minus B3 and take absolute value. Okay. So now you drag it down, copy down the formula. Make sure you see fill handle. Your mouse must be on bottom right corner. Double click. Okay. And then take the average of all these values. So I will calculate the average, AVER, AGE. Take the average of all these values. Okay, and press enter. So this value is MAD. This is my MAD, is 0.188. Okay, this is how you calculate MAD. Okay. So any questions? All right. So that kind of conclude. This is example about MAD. You are supposed to know MSE. Maybe since I'm here, I will also compute. So this is MAD. Next, how do you calculate? This is question. Question 20. Yeah, question 20. How do you calculate MSE? Okay, MSE. Next, I'm going to calculate MSE. Okay. So again, you need to know the formula for MSE. So the formula said mean square error. Use original data YT minus YT hat. Okay, square it, and then add them all. Sigma means add them all divided by n. Okay, this whole thing is MSE. And when you use Excel, you just do YT minus YT hat square. Do this one, and then take average. Take average of this guy, that is your MSE. Okay, so I'm going to show you how to do MSE. So now I need something square. YT is A3 minus YT hat is B3. Okay, B3, and then square it. So that is YT minus YT hat square. Okay, so far I did YT minus YT square. I did this. Next, copy down the formula. Last thing, you calculate the average of what you get. So equal AVER, AGE, average of this number. And this result is MSE, 0.05. Okay. All right, any questions? That conclude chapter 2. Okay. Let's all take a break. After break, we'll do chapter 4. Okay, I'm going to stop recording. When we come back, I'm going to start recording again. So come back at 7:30. Okay, back at 7:30. So where is stop button? When we come back, please remind me to press record button. Now I'm going to, where is that button? Okay, it's here. Where's the recording button? More. Stop recording.